All right, so looking at class number 97, we're going to introduce something called electron volts. Now, everything we're doing can be done without electron volts. We could use the units of joules for energy, but sometimes it is advantageous to use the units of electron volts for energy. We'll try to look at each one and look at the advantages and disadvantages, but just realize that you can do any problem in either joules or electron volts, but usually one way is easier depending on your givens and depending on the answer choices in a multiple choice question. So number one says a 1-volt battery is used to power a flashlight. How much kinetic energy does this battery provide a single electron in the flashlight circuit? So we know the voltage, 1 volt. We know the charge of a single electron, negative 1.6 times 10 to the negative 19. So we're looking for the energy work, W. So working through this, we get an answer of 1.6 times 10 to the negative 19 joules. All right, going through the math there. But physicists don't like to deal with numbers this small because frequently when we're dealing with really, like, let's say a nuclear physicist, they're dealing with tiny particles, just a few, not even a whole coulomb, like 1.6 times 10 to the negative 19, 3.2 times 10 to the negative 19. They don't like dealing with these tiny, tiny numbers they get. So they made up their own unit called an electron volt. And it's kind of self-explanatory. An electron volt is the amount of energy gained by one electron in a 1 volt potential difference, or in a 1 volt battery, whatever, circuit. So if you rework number one in electron volts, you do things slightly differently. The voltage is still voltage, 1 volt. But Q, instead of doing negative 1.6 times 10 to the negative 19 coulombs, just write one elementary charge, or like one electron. But you would also write that E for a proton as well. Now when you go through the math, you cross multiply, you get your work is equal to 1 E times 1 V, or 1 EV, 1 electron volt. That's it. And the electron volt is very frequently used because it's just easier to work with. Okay, so that's why we made it up. On your reference table, find where it is on the front page. 1 electron volt is equal to 1.6 times 10 to the negative 19 joules. So you could always go back and forth between electron volts and joules, but generally, depending on your answer choices, will tell you which way to do it. So let's look at this question that, we'll do it both ways. So we have a proton, and it's in a potential difference of 10 volts. How much work in electron volts was required to move this proton? So in electron volts, really easy. Voltage is 10 volts. Q is 1 E, meaning 1 elementary charge. Find W. Plug it in, cross multiply. V equals W over Q. You get 10 electron volts is equal to the work. Now let's do it without that, doing joules. Well, in that case, Q would have to be 1.6 times 10 to the negative 19 coulombs. Still not that bad, but you end up getting a work value of 1.6 times 10 to the negative 18 joules. All right? Just not a fun number to work with. 10 electron volts is much nicer and cleaner than 1.6 times 10 to the negative 18 joules. All right? So make sure you work through the math there and kind of see how to work through each one. So electron volts and joules can be converted to and from each other. Again, this is on your reference table. 1.6 times 10 to the negative 19 joules equals 1 electron volt. So if we have 13.6 electron volts, we want to get it into joules, well, we have to multiply by 1.6 times 10 to the negative 19 joules over 1 electron volt. How did I determine to do that? Well, I know that 1 electron volt is equal to 1.6 times 10 to the negative 19 joules. So the unit I want to convert to is on the top. The unit that I have is on the bottom. How do I know I did it right? Well, the electron volts cancel. Multiply straight across, so you get 2.176 times 10 to the negative 18 joules. Now let's look at the next one here. We have 4.5 coulombs of charge, and it gains 5.4 times 10 to the negative 12 joules of electric potential energy. How many electron volts is that? So you actually don't need the number of coulombs here, you just need to convert. So we want electron volts, so we put that on top. We have joules, we put that on the bottom. So again, 1 electron volt is equal to 1.6 times 10 to the negative 19 joules. This fraction is equal to 1. That's why we're allowed to multiply by it. Joules cancel, multiply right across, and don't forget to divide, and you get that number there, that number of electron volts. All right. Now let's work through a couple of these. Notice how the answer choices to 7 and 8 are in electron volts, so I would deal with the electron volt method. So an ionized calcium atom has a charge of plus 2 elementary charges, so I would say Q is equal to 2E. Okay, you could write 3.2 times 10 to the negative 19 coulombs, but trust me, this way is easier, especially since your answer choices are in electron volts. If you wrote Q as 3.2 times 10 to the negative 19 coulombs, you would have to then convert it to electron volts. Okay, just an extra step you don't want to do. You're given the voltage of 2000 volts, looking for the energy. Now, a hint to electron volt questions. Generally, you should not need to use a calculator for an electron volt question. So Q is 2E, voltage is 2000 volts, plug it in, cross multiply, you get 4000 electron volts here, or 4 times 10 to the 3 electron volts. The next one has 3 elementary charges, so Q is 3E, and the potential difference is 4.5 volts, that's the voltage. Plug it in, cross multiply, and you get 13.5 electron volts. Again, you really don't need a calculator if you do the electron volt questions properly. All right, so how do you know when to do electron volts? How do you know when to do joules? How do you know when to make Q 3 elementary charges, or 4.8 times 10 to the negative 16, or excuse me, 4.8 times 10 to the negative 19 coulombs? It's kind of a practice, but it's also looking at what you're given. Notice how your answer choices are in electron volts, okay? So this was an exit ticket question. Basically, I gave a situation where I told you there's an alpha particle, which has a charge of +2 elementary charges, and a 1.7 megavolt particle accelerator, which is 1.7 million volts. What we did was we plugged that into our equation here, and we got that the energy was 3.4 million electron volts. Converting that into joules, again, joules on top, electron volts on the bottom, 1.6 times 10 to the negative 19 joules per 1 electron volt. Electron volts cancel, and you got something, I don't remember what it was, to the negative 13th power joules. All right, that was just like an exit ticket question. All right, so just make sure you're familiar with how to do these questions here and how to do it in both the electron volt method and how to do it the joules method. The electron volt method we did mostly in class. The joules method we did in the previous class. All right,